So we'll start with some easy questions. So let's say I give you a sorted array of integers. Okay, this is sorted and this can contain duplicates. Okay, the sorted array can contain duplicates. Now you have been given a key, and what you have to do is you have to find its index of first occurrence. You have to find the index of first occurrence of the key in the given array. So let's say your array is 1 1 2 2 2 3 4 4, and let's say your key is equal to 2. Yeah, so what should be the answer over here? What is the index of first occurrence of 2? Yeah, so 2 is occurring at multiple indices, index 2, index 3, index 4. So here the output should be index 2 because I am interested in the index of first occurrence. So how many of you can solve this problem? Yeah, lower bound function is present in C++, but you should not use that. Can you think of implementing on your own? So quite easy. Okay, how many of you believe that I will be able to detect the first occurrence by using the last code that I had written? Will the last code give the correct answer? Think again before you say yes. No. Why it will not give the right answer? Because the last code, whenever it was at a middle point where a of mid was equal to the key, it immediately returned m. So let's say if it hit this midpoint, then it would return me this index, but I do not want this index, rather I want this index. Is it clear to everyone? So yeah, so the last code is not going to work definitely. Okay, so then how do I solve it? So I'll just try to tell you some of the approaches that I have heard from some of the students who are attempting it for the first time. Guys, tell me one thing. I'm interested in the first occurrence, right? So if let's say a of mid, anytime let's say I have a mid value, if a of mid is greater than the key, what should I do? Will the condition for this case be exactly same as the last case? So whenever a of mid is greater than the key, I need to move to the left. And how do I move to the left? I simply move to the left by doing high equals to m minus 1. And on the other hand, if let's say at any point of time a of mid was smaller than key, then I need to move to the right. For this I need to do low equals to mid plus 1. So for smaller than case and greater than case, the change condition has to be same. Is that clear to everyone? For these two cases, the change condition has to be the same. Which condition is tricky? The condition where you land at a value of m such that a of m is equal to key, that is tricky because you do not know whether this can be your first index or something before this can be your first index. So under this case, can I do something like this? If I check that a of m has become equal to k, which is my key, then I know one thing for sure. Either this will be my answer or something which is in the left of this can be my answer. Is that true? Yes, no? That is true. So can I do one thing over here? I will start running a for loop from here till the end as long as I am getting 2. The moment I get something else, the last index where 2 was there, that would be my answer. How many of you think this approach is right and is functionally correct? This is functionally correct, perfectly correct. But is this an efficient approach? Will it have a time complexity of log n like binary search? No. Why no? Because in the worst case, it can end up taking order n time, right? How? Let's say the entire array contains the same element, okay? And you are searching for 2. So you will end up at a midpoint and then you will run a loop which will make you do order n by 2 iteration, which is order of n. So this is just like performing linear search after certain iterations of binary search. And the moment you perform that linear search, it will be back to order of n. Is that clear to everyone? Why this approach is not an efficient approach? Yeah. So what should be the efficient approach? So whenever you are using binary search, you should always use binary search. You should never start linear searching. You should always be able to pick up an area where your answer can lie. Okay, so as all of you already agreed to this thing, if let's say your a of m is equal to k, that means your answer will either be this thing itself or it can be in the left portion. It can never be in the right portion, isn't it? It can never be in the right portion. So how do I distinguish these two cases? First case is that wherever my m is, that is my answer. So for that, what I can do, I can compare a of m with a of m minus 1. So if a of m is not equals to a of m minus 1, if let's say my m was here, you would have seen that a of m is not equals to a of m minus 1. In such a case, could you easily have said that this m itself will be my answer? This m itself will be my first occurrence, right? So if this is the condition in association with this condition, then you can say that return m. But if this is not the case, let's say something like this. If this is not the case, that is if a of m is equal to a of m minus 1, does that mean that, hey, my answer will definitely lie in the left? Does it mean my answer will definitely lie in the left? Yes. So what should I do over here? Whenever you move to the left, what do you change? Low or high? You change your high. So you would do high equals to m minus 1 and you would now do binary search in this portion, which is from low to m minus 1. Is it clear to everyone? Did everyone get it? Okay. Now tell me one thing, while you are writing this logic, you will have to write this line of code. Can this lead to some problem? By that I mean, can there be certain corner cases while writing this code? The answer is yes, there can be corner cases. What if at any point of time your m was 0? So when your m was 0, you would end up comparing a of 0 with a of 0 minus 1 and this will give you index out of bound. Okay. So how will you handle this case? Can somebody tell me how can this be handled? This is very easily handleable. Yeah. So what you can do is, if your a of m is equal to k and m is equal to 0, does that not tell your common sense that, hey, this m itself will be the first occurrence? Does it say yes, no? That's it. So this is the only edge case that you are supposed to handle. So I think then the logic becomes very simple. For greater than case, this is the logic. For smaller than case, this is the logic. For equality case, if m is 0, then simply return 0, because that would be the first occurrence. And if m is not 0, then you can safely perform this comparison. Then you perform this comparison. If a of m is not equals to a of m minus 1, then return m. And if they are equal, then you do high equals to m minus 1, because in that case your answer will lie in left half. How many of you can write code for this case? Just say yes, so if you can write? Okay, great. So I'll just quickly write. So you initialize your low and then you initialize your high to n minus 1, and then while low lesser than equals to high, m is equals to low plus high by 2. See why I am writing this condition, because I told you my low and high are inclusive bounds. That is the reason. Okay, keep this thing in your mind. Now as I said, if a of m is greater than key, if a of m is greater than key, that means I am in the right side of my answer, so left side should be of interest to me. To do that, I'll do high equals to m minus 1. Okay. Else if you see that a of m is smaller than key, that means you are in left side of your answer, so you should go right by doing low equals to m plus 1. Else means equality, that a of m is exactly same as your key. So here you need to compare a of m with a of m minus 1 to figure out whether it is your first occurrence or not. But first handle the corner case. So first check if m is 0, simply return m. Okay. Else if you see that a of m minus 1 is not equals to a of m. If this is the case, that means your answer should be towards the left. To do that, you will do high equals to m minus 1. Okay. Else you will simply return m. Is everyone clear with the code? Yeah, what will be the time complexity of this code now? This will be exactly order of log n. Why order of log n? Because every time my search space is being halved. Okay, can you guys write a code to detect the way I have detected first occurrence? Can you detect the last occurrence also? So if let's say you want to detect the last occurrence, will these two conditions remain the same? The first two conditions will remain the same for sure, right? The condition that will change will be for equality case. So let's say you want to search for the last occurrence of 4, and let's say you have 4, 4, 4, 4, okay, and then you had a 9 over here. So if let's say you are here, then you will try to compare a of m with what? You will try to compare it with a of m plus 1. So if you see that a of m and a of m plus 1 are different, then this itself is your answer. But if they were same, then you would move to the right side. To move the right side, you will do L equals to m plus 1. This is the only change. Is it clear to everyone, guys? Now here also, can a corner case happen of index out of bound? When can it happen? When the last occurrence is at the last index. Yes. So can you take care of that? You can, right? Just like here, whenever you see m is equals to n minus 1, that m itself will be the last occurrence. Yes, no need of comparing a of m with a of m plus 1.